We come to order here and have a conversation about this. Did we finish? Thank you guys. And you. Thank you. Appreciate it for your attention. Did we finish our discussion about this? Okay. I think we finished, obviously we did because I pulled the PowerPoint up and we had written these in. We did finish talking about the cumulative frequencies, and we started, I think, talking about why they're useful in answering these questions. I think we talked about the median, yes, and why it's located for 600 pieces of data at like the 325th piece of data. Do we have that top? Right? Maybe? Like in between the 300 and the 301st piece of data. Okay, so then, did we get to the place where we had a conversation about how to find, say, the 44th percentile?
Yeah.
Yeah, 0.44 times something. What is it? Let's do it. 0.44 times 600? Yeah, it's actually 601, which is a little tricky, and that comes out to something. 264.44 something. Okay. All right. Good. And then that tells you, what does that tell you? That's not the 44th percentile. That tells you where the 44th percentile is located, right? And that might tell you that it's like in between the 264th and the 265th piece of data on the list. Now, that was a very extensive conversation to arrive at the following answer. What is the answer? What's the 264th? And the 265th piece of data? 2, right? So that was like maybe a little heavy hitting for like such an easy thing to write down in the end. But have you seen why the cumulative frequencies are useful in making that determination, like where the 264th piece of data is? Is it clear that it's a 2? Okay. I hope you see why that's useful. Yeah, Cheyenne.
Why do you multiply by 600?
Yeah, so let's go back to the median. The median is also known as what percentile? Yeah, it's the 50th, right? So let's use the same formula here. If you want to find the 50th percentile, the median, you're saying let's multiply 50% times 600. And when you do, you get 300. So is that the piece of data you want to go to, the 300th piece of data? Actually, no. You want to go, like we said, to the 300.5th piece of data, don't you? So, do you see that 0.5 times 601 does a better job of that? Let's scale it down to 6 pieces of data, right? If you had 6 pieces of data, you'd want to go to like the 3.5th piece of data, right? What if you had 7 pieces of data? Does the formula work for 7 pieces of data too? What does it give you? I mean, if you just say, oh, it's 50% of 7, then you get 3.5, but that's not the answer you're looking for. Yeah, you're looking for the 4th piece of data, so we need to do 7 plus 1, which is 8. Divide that 2. Yeah.
Because it's like 264.44, right?
Yeah.
So does it matter that it's 0.44?
In this case, not at all, because both the there's no controversy here, because the 264th piece of data and the 265th piece of data are both 2s. So like, yeah, but if they're different, this is actually as like silly as finding percentiles might seem. This is actually like a contested point, where different pieces of mathematical software calculate it in different ways. Yeah, he's saying, if you're in between, if you're looking for the median, you're looking for 300.5th piece of data in between 2. It's obvious that you average those if they're different. But what do you do if you have like 2 and 3 and you come up with something like this? If this was 2, what would you say? I don't know. I'll put it back to you guys. Round it? Yeah. Yeah, maybe make it like 2.44 or something. Go part of the way but not halfway or something. I don't know. And all those are good answers. In fact, did that come up on this night? I think someone brought this up, the 98th percentile. What was that?
588.9.
The 589, 88.9, 9th piece of data. So that's exactly the question you have here, right? It's like, what happens here? This actually does fall in between the 4th and the 5th piece of data. But I think I would be hard pressed to just be like, well, let's call it 4.5. Right? Because it's kind of more 5 than 4. But we would forgive you if you said probably either, right? I think, I don't know. You could even say, like, I don't know, maybe you linearly interpolate along the way. Okay. 4.9. I don't know. But I think different people would say different things about that, so we'll accept any reasonable answer there. Yeah.
So like, if it was
still average them, but I mean, we'll give you permission to do that, but it does, this becomes suspicious as we get closer and closer to the end. We're like, maybe averaging isn't what we should, I don't know. But in the end, this is like a wash. Normally we're dealing with such large data sets that like, who cares, right? Whatever. For small data sets of 600 PC data or something, it's not, it's a big deal. Let's have a conversation about class data a little bit, or grouped data, or binned data if you want. The big task, before I go through like the instructions on how to like create bins, I just want to make sure you don't lose sight of the fact that like if I just said, hey, could you sort this data into 10 bins, you would probably, without my guidance, after a little bit of pursuit, get the right kind of thing I'm looking for, right? By 10 bins, I really just mean like put these in 10 boxes, right? It's not all we want. So don't lose sight of that, and I think you would probably do the things I'm about to do too. You might not like have special words for all these things, but you would probably end up doing the same thing. And before we put them in bins, let's just stop and recognize that this is like a thing we want to do. Imagine, this is just a tidy little data set for us to work with, but imagine that you were dealing with like this setup data for everyone in the whole school, right? 23, 100 something students. You can imagine that it would be unwieldy, like if you wanted to publish this result in a magazine or something like that, you're like, well, here's the data. Oh, not useful, right? But like maybe we could create some boxes for them to go in, you know, make some visualizations of the data, some charts, whatever. So I think this is a worthy cause in that end. Just to even just start getting a handle on the data itself. And then we do have other motivations for doing this as well, which we'll talk about as we move into tomorrow as well. So, am I right that this is what you would do? You would find how big each bin would be by finding the lowest and the smallest value and finding that distance. In this case, sorry, the spacing is a little weird up here, but 97 minus 22, I found the largest and the smallest amount. Are these reasonable, by the way, numbers for the sit-ups that IB students do? I don't know. In a minute.
Why do we have any zeros?
There are no zeros?
Some of us can like not do anything.
I figured all of you could do 22 sit-ups in a minute, but maybe not. All right. So I make up these numbers, and sometimes I get them wrong. Okay, it's all good. Okay. And then wouldn't you divide that range, that size, by 10? And when you do, here, you get 7.5. Now, that can't be our bin size for this data. Do you see why I'm choosing 8 to be the bin size? It has a question waiting for you here, and it's not answered in the packet. Can anyone explain the answer to this question? What I'm saying, even if you have 7.1, I'm going to say round up to 8. Why? You want to take that one?
Because if you don't really know enough, which is like extras.
Yeah, again, we're all in the name of like putting things in bins. And Corinne is saying that if you round down, you run the risk of like being really good until the very end. You might like lose one piece of data. It's like not in a bin. So just be really careful about that. Little errors sometimes add up and mean you're just a little too short on your bins. So always round up just to be safe. Yeah.
Oh wait, never mind.
Okay, so that's a good conversation to have. That number 8 we just determined is called the class width. That is the bin size, okay? And then we can now form for each class, actually name the range that we're going to have for each class. And we call that the lower and the upper class limits for each class. So it makes sense, I think, without a better guess for it. Let's make 22 the lower class limit of the first class, since that's the lowest piece of data we have. We'll capture it. And then each class will start 8 units higher, right? You see that? Well, if the next class starts at 30, then this class must be capturing sit-up numbers from 22 up to 29. But not 30. That would be a problem. Why would that be a problem if we did 22 to 30? And then 30 to 38? Yeah, if someone does, and they're certainly allowed to report a number of sit-ups equal to 30, that's okay. Then which bin do they go in? That's a problem. So you can see that. Now, it does propose an interesting thing here, though, and that's that, like, 29 minus 22 is not 8, right? So just to be clear, 8 now gives us, though, the distance between lower class limits, or upper class limits, if you like. But this in here, class interval, whatever you want to call it, is 7, actually. But it does actually contain 8 numbers still, doesn't it? 22. Yeah, figure it out, yeah.
So if you have like a thing, because those are all integers and they don't have like decimal points.
Yeah.
But if you had like, on the homework it says like 17.3 to
Yeah.
42.7, like that's, how would you decide, like what to round it up to? Like if you had a really weird decimal answer for
Yeah,
that.
round up, you mean for coming up with the class width?
Yeah.
Yeah, so you round up to whatever the precision of the data is. So if you're doing integer data, round up to the next
Because
integer.
it says like 17.3 to 42.7, so would I just like round to 0.3 if that was like the closest one?
Yeah, so say it again, what were the numbers?
17.3 to 42.7. That's like the maximum.
The minimum and maximum. So let's assume the data is reported in tenths. Right, so when you do this, and how many classes do you want? So you're going to do this minus this.
12 classes.
So you're going to do this minus this, divide by 12, and you got what number?
2.116.
2.116.
Yeah.
Okay, so round to 2.2.
Okay.
Do you see what I'm saying? Round to the precision of the data and round up. You hear that? People in the crowd? Okay. I would make that the class width. So then already, do you see that now when we go back to the data and start putting them in bins, already this is not maybe beautiful, but it's certainly something we could much more easily report in like a glossy magazine or a paper or something like that. Much more digestible. Very nice. We get a real strong sense that like this is where most of the data is. We can see that, so, and they're all equal width bins, so we get a sense already of the distribution. But then we might also, and also if you're doing this by hand, by the way, I did this for you, but do check, like it says, check that this adds up to 60, right? And in the name of maybe moving toward a graphical display of this, let's create these new boundaries. These are called, instead of lower class and upper class limits, these are called lower class and upper class boundaries. And here, I think you can see what I've done. I've taken the lower class limit of one class and averaged it with the previous upper class limit, right? I've kind of found the halfway point in between them, which will always be like, in this, for integer data, it'll always be like whatever, 0.5, right? I've also expanded the lower class and upper class, though, even though that wasn't necessary. You wouldn't think it's necessary, because the thing is, two things I'm looking for is for all the classes to have shared boundaries at the edge, so there's no space in between, and every class has the same size as well. And if you don't expand here and here, that won't happen. So notice now that they all actually do have a width of 8 here, and the difference going down is 8. So that's like kind of solves that problem a little bit. And then there's only one other issue that we had a minute ago, and I want to consider it with you again. Is it an issue that they share a boundary? Why isn't it an issue? Yeah. Yeah, we're not like we already shook on it, right? No one is reporting about it. You're not allowed to report a number of sit-ups at like 29.5. If they were, that would be a problem, though. Yeah.
What about if it was 0 and it was like time? You can go down to like.
Yeah, we're still gonna push into the negative. Yeah. Because we really are going to eventually create a histogram, and we want the area of the histogram to be meaningful. We're going to be moving toward like frequency curves of various kinds, where the area under the curve is something that we care about. So we really do want to like move in that direction. Yeah.
What do you if the values that you're giving for the set of numbers contain how do you
If the numbers contain what?
adjust them? So if the numbers were like if some of the numbers and stuff were 45.
Yeah, exactly. Then you'd have to everything we're doing would have to be one decimal place more, right? Yeah. And then once you do that, it's easy to show how you can make a histogram with that. You can see how my previous values on the chart relate to this representation. I've labeled it nicely, frequency, all that, right? Okay, so I hope that guides you a little bit in your thinking of how to organize data that's in classes. Let me also give you, at this point, a few words of introduction to statistics too, the kind of thing that you would have maybe heard before, or maybe not, just to make sure you're on the same page. And again, I apologize to AP stat people a little bit. Some of this will be with you, but it'll be good. It's always a rich conversation. So and I think this is what the homework tonight has. I have a little addendum to add to it. It has to do with it as well. I'd like you to be able to answer questions about the following words. Okay. We have classifications for data. Here are the two big classifications: numerical or quantitative. Things that can be measured or counted. Examples include the things in yellow. The second classification I might give is categorical or qualitative data. And examples of that are in yellow. You see the difference. Now, with those examples in mind, and others that you might bring to the table, can you think of data that could go either way on these, that maybe seems numerical, but actually isn't? There are kind of some classic examples of this. Yeah.
Favorite number.
Yeah, I think to some extent that might be true, right? Like, is it meaningful to, like, average everyone's favorite number and come up with, like, the average, which is everybody's? This is like the average of our. That doesn't. It's like no longer. It's not as meaningful. We're kind of treating them as like favorite colors in some sense. Yeah, even though it seems numerical, it's kind of not. Yeah.
Wait, I don't understand the difference between them, because can't you like measure both of them? Like if you ask everybody what their favorite color is, then can't you like
Yeah.
with, like, a
But then
chart?
how are you going to plot those? Right? There's not like an axis to plot them on. You could just place like, well, blue, green, yellow. I don't know. You could just like, maybe you could. Now, actually, let's take that example. Could you make that though quantitative somehow?
Yeah.
How?
Color spectrum.
Huh? Yeah. Maybe by like wavelength or something like that. You could actually like, please report your favorite color in this survey by wavelength on the electromagnetic spectrum. Right? That would be classy. Okay. And you'd be like, well, I was gonna say blue, but I don't actually know what that is. I don't know.
Could try to average your favorite.
You can do like RGB values or something. Or I don't know, something. Yeah. So maybe some of these could be.
Or you can do pay.
Maybe some of these could be made quantitative somehow. I don't know. There's always room for exploration between the two classifications. What about discrete versus continuous? Have you heard this distinction before? Inside of quantitative data, inside of that classifications, we might talk about discrete data. That is, like things like this yellow example, the number of students in a class, or the number of sodas you purchased at Safeway yesterday, something like that. You can't like buy continuous spectrum of different amounts. It's like discrete values, right? Continuous data arises not from being counted, but from being measured. So the typical example of that would be times, heights, weights, things like that. Cost to some extent, right? And again, maybe you can think of something that seems discrete but is actually continuous, or is continuous but you could make discrete somehow. Really, we have like deep questions about the universe at this stage. Like, is time actually continuous? You know, things like that. You can go ask the quantum theory people about all that. Whether the universe is discretizable. All right, so would you now engage in this? You pull away a little bit here. Just turn to your neighbor and tell them what you think about each of these, whether it's qualitative or quantitative, and then whether it's discrete or continuous. I'm trying to draw this on your paper or something.
Oh, yeah. That's fine.
Yeah, it's change the window scale to one of your classes.
Continuous or give this try to get half, quarters, or however far down you
Try
want.
that. All right, let's take a vote on these. Are you ready? Okay. Is everyone confident in their answers? Okay. Qualitative or quantitative? For this first one, qualitative. All in favor? Quantitative. This is the place where we should have fights. Anyone want to fight? Good job.
Square up, everyone.
No one wants to fight on that? Okay, all right. Could you make it? Could you make it quantitative somehow, if you wanted?
Yeah, you can change those numerical values.
Yeah, you could like rate it on a scale, and in fact, someone might want to do that, right? So that you could actually like the average quality of textbooks returned.
Is
Yeah,
7.24.
right. Exactly. What about number of customers at McDonald's? Qualitative or quantitative? Qualitative first. Qualitative. Quantitative. All right, now let's ask the other question. Discrete. Continuous? No. You want to say continuous? It's all good. Time it takes to finish an 8K race? I don't know who runs 8K races, but there it is. Okay. Quantitative? All right, what are we doing? Qualitative first. What do you think? Qualitative? Quantitative. Discrete? Continuous. Okay. No one wants to fight on any of these? You don't want to fight? Okay. Height of a newborn child. Qualitative? Quantitative. Anyone? Okay. All right. No one wants to fight that. What about discrete? Continuous? All right.
Well, you could say discrete if you went by the idea of the length, which is the smallest measurable distance in the universe, but I don't think anybody wants to do that, so.
Well, maybe you do. I mean, maybe you, I don't know if we can reliably measure in that way or not.
Considering this the way
But
that's small possible.
I think we'll consider continuous. Do you think that you were ever exactly pi feet tall? I think you were, right? Weren't you every height between 0 feet and your current height? Things just got really easy. Were you ever 0 feet tall?
I was -3 feet
Like I said, it's getting philosophical. Number of errors on your last math quiz. What do you think? Qualitative? Quantitative? Discrete? Continuous? What you want to make? You want to be the lone fighter for continuous?
No, but if you're wrong, you're wrong. If you're not wrong, you're not.
What if I have multiple errors while
You're a true math student. I like it. Yeah.
doing
It's not right. In English class, maybe continuous. In math class, discrete. Number of
I
errors.
have a 30th of an error in my math course. What do I do?
Yeah. Well, what about points? This is an interesting question, guys. What about points? Even if I'm not the kind of teacher that takes half points off. Excuse me.
Then that would only leave you with the scale.
Eric,
So then you just go outside and talk to the student in the hall.
stop loitering.
He's a loiterer. What do you expect?
All right. Where was I? If I was the kind of person that took off half points, would that make my pointing just a continuous thing? It would still be discrete, right?
It would just be by half points.
It would just be discrete by half points. On a 50-point test, there would still be like 100, and only 100 things I would ever take off, right? I don't know. Maybe we should grade that way though. Minus 2.3475 points for you.
You get a minus 1.935.
We can visualize our data once we have these histograms in our lives, and eventually these curves, as being either symmetric, possibly, or skewed. And there are other distribution shapes, but these are important words that we want to be able to use as well. So, have you used these words before, you guys? Skewed left and right? Sometimes it's hard for me, at least, to remember which is which. Skewed right, I kind of think of taking a symmetric distribution and grabbing it on the right, it's like made of Play-Doh, and like skewing it to the right, like pulling it to the right. And when you do, the mean moves to the right, but the median will stay generally where it is. And the opposite is true for a left skewed distribution. Think about like the weeds around Miss McDonald's house that we were studying. You remember the 78.1-inch weed? Imagine you made that instead like 20 feet tall. Right? Can you imagine like changing that data point? Well, the mean would get dragged way up, wouldn't it? But the median would stay exactly unchanged as what it was before. Okay? So, that's my comment about that. So, make a comment in response to this data and these two things that these two people said. Take a second and reflect on it. Tell your neighbor what you think of these comments.
And this is when you can just care about each other.
What do you think? I think that's one each. That's all the employees. There are only 8 employees. All right, in this 8-employee company, what would you like to say about these two comments? You know, these two people at a cocktail party and they're like, you know, sharing with friends. Like, I work at my company. This is what he says to his friend. What would you say about these? Just give me your gut feeling about these. About Cheyenne. What would you say?
I said with employee because it's only president and vice president that are getting like huge salaries, and that's really skewed, right?
Yeah, this is like, and you even use the right word. This is like skewed right, isn't it? Yeah. Anyone else want to add to that at all? Yeah, in some sense, the president is not lying, right?
Wait.
Yeah.
Something's skewed right, like it goes like that. Is the mean higher than the median?
Right.
Skewed right versus median left.
Yeah. Go ahead.
The mean always goes to the median.
Did you have something to say again, or you just said?
I was going to say that this isn't even the most confusing statistic people could ever see.
Well,
I mean,
okay.
if you see politics, those statistics can get weird because if jobs are lost and they're gained back, then you could use a certain chunk of jobs lost. For example, if women lost their jobs during, say, the 2008 election, Obama was accused of losing 70% of his jobs being women, which was both true and false because a lot of those jobs were gained back at the same time.
It's easy to lie with statistics, right?
Mm-hmm. Anybody can make up statistics for a point. 53% of people know that.
Let's move along. The last slide in my set of things I wanted to say to you, and I promise I'll let you be. I know some of you are anxiously working here, wanting to get to some of this stuff. Is this idea of a population and a sample, and for our purposes in IB, at least for now, we'll assume that we're always like only talking about the data under consideration. We won't ever, from that data, try to be making any inferences about a larger data set from which that's taken. That is certainly a very, very important idea in statistics. So you should take AP Stat if you're not taking it yet. Okay, so that's our plug for that. So is that a good kind of overview of some of the terms? I just like to be able to like use those words, categorical, discrete, sample, whatever, and know what you know that you know what I mean by those words. So I felt like I needed to say them. So continue working on homework 1, and let me also give you a little addendum as well. Just this little piece that asks some of these questions. Just ask, is this quantitative or qualitative, like that kind of stuff, right?
So the thing about that is like quantitative and qualitative are like the same no, like it's just hard to like I hate writing the word out.
Yeah, if you I should like send you the data on the back page. Yeah, on the last page, if you want to just do one of those, that would be okay. On the back page.
Wait, like I was three or
Somebody on fire. You wouldn't be reminded.
I just mean like, there's no benefit really.
I just
Wait, but there's so many other ones. Because you have to make a 7-page plot, and I don't want to.
I can give you a presentation of that.
Can we just not do this one if we do this one? Because this is a separate plot. And now I'll just describe the spread. I don't know. Shape Say yes.
What do you feel like you need to do?
I don't need to do this because I already know 7 plots.
You don't like it. Like, I feel like maybe just like
So, yeah, hey guys, on the homework 1 packet, and feel free to tell your friends in my other classes this too. If you wanna on the back page only do one of those, that would be okay with me. On the very last page, on the homework 1, there's like 2 very large data sets, and there's not a huge benefit probably in doing both of those. I don't know. So, and then maybe apply that logic elsewhere if you feel like there are 2 of something that you don't need to do 2 twice. Like do the ones that you feel like you need to do, and cover 80, 90% of the packet. Is that okay, Leo? 87% of the packet.
How about if we miss one page?
If you missed one. If you missed 1 page, you go ahead and forget it. But if you missed it. Do number 14. Because we're going to need that for a while. Just number 14. Yeah. Yeah, that's fine.
Why is shoe sizes on page 1? My shoe size is
There you go, like distance and like time, therefore technically all of this is discrete. All real world applications are technically discrete.
Whatever you need to do.
I see a very large problem with this. Everything that is a real world application is discrete due to Planck units. Planck units are the smallest units of anything, being with the black hole. They use get used by yeah. Oh yeah, there's a unit of Planck. That is the smallest measurable amount of time.
It's like using like 6
I was so it's what you
Well, we can always jump into a black hole and find out, but we never get out.
I think those are still relegated to like
Like, you could always try to test it. What happened to you would probably be your own fault. Literally turn into a string of atoms as you fall in. Oh yeah. You can
I'm good at writing and reading. I'm bad.
not even get any more.
So that's why I feel like I know for the APs you have to talk to people. Something about the culture. So I can't talk to people. Yeah, I'm just like, literally like, how do I say my dress size is
Capital is
Well, I hate like all the shoe sizes. Like they're like, you're 25. Why are you size?
no, but like every company has a different like standard shoe size. It's just not all you have. I've been forced to take a lot of time. How much is
great. Read Welcome to the Universe by Neil deGrasse Tyson, Michael A. Strauss, and Aaron Schott.
Never watched the movie Coco.
Oh, why is
How did Willy Wonka teaches you a way to that just sit around and do nothing?
It's actually by the way these guys science it. Yeah, science it. Red is better than science is a verb.
Wait, what is the context?
Sciencing is the verb form of science as a carrot. That's how English works.
Systematically killing the children. What do you mean, like, you want each toy to be like, just enough seats for all?
Live and you look the same. Like people do. Yes, no one
Show me me.
No, that's me God. I'm strong with the
Or killing. What is that?
Have you
my calculator, and I don't know if it's because I sort of know how to do it. I just mix it.
I listened to you guys. It had designs on it. Listening to you guys about it and describe it better. Right, but I need to like push it so it doesn't show up. Because you'll something happens later. Sherlock Holmes.
Did you stop caring?
Have you ever watched Sherlock? You've never even heard the name. No, are you kidding? In middle school, people would be like Sherlock that. About Sherlock, he's a detective. He's like brilliant at everything. And then he's like, you're without knowing me, you're like, you're a child with yellow hair. Yellow hair.
Are you okay?
Have you watched Ferris Bueller's Day Off? Here, look. I don't know if you like my
Make it base first.
Wait, how about like,
I mean, what do you want to make?
I would make a fancy cookie instead of, I really just like, we'll give me
Probably with me.
I know, right?
Yeah.
You watch this really? I'm so
Find out why the center part of donuts is soggy. Made the donut.
okay, the other day, they looked at it like Charlotte's Web.
Very funny.
Today. Bye guys, see you tomorrow. Do 87% of the homework. Good.
I'm just not, I don't know.
Does that make sense? But that'll do it. See if it comes up with these answers. 2.35 for me.
Yeah,
I'll tell you what to do.
that's what it is. Yes.
You guys problem solve Google. Number one result on Google for the rest of you.
Miss my bus.
You're not gonna miss your
I
bus.
am. I have to go down to my locker. Okay, should I just not go down to my locker?
You should follow your heart.
My heart is telling me to go to my bus.
Did your bus really leave like with that kind of
My bus has left without me before, and it probably will again. But
with that kind of
frick, it's gonna thunderstorm. I have to get my foot. Bye, Mr. Chase.
yeah.